Everyone. In this video, we'll define two terms, atomic number Z and mass number A. This is an aluminium atom right here. Like any atom, it has three subatomic particles. The protons, which are positively charged, neutrons that are neutral, and electrons, which are negatively charged. Protons and neutrons are located inside the nucleus. Electrons move around the nucleus in shells or energy levels. Basically, atoms can be represented by their chemical symbols. They're represented by two numbers, which indicate the number of each part in the atom. These two numbers are the mass number and the atomic number. Now let's figure out the number of each particle in an aluminium atom. So it has 13 protons, 14 neutrons, both are in the nucleus, and 13 electrons, pointing around the nucleus as energy levels. Now we'll start with the number of protons. Usually it's written on the lower left of the element. So the symbol of aluminium is Al. To the lower left, we will write the number of protons, which is 13. This is the atomic number or the proton number Z. So Z, which is the atomic number or proton number, indicates the number of protons in an atom and it defines an element. Now, on the upper left, we have the mass number A, which represents the sum of protons and the neutrons inside the nucleus. 13 plus 14 will give us 24. The mass number A is equals to 24. So if we have the number of protons and the neutrons, mass number by adding the two numbers together. Now, what if we're given the mass number and the atomic number? So basically we have the A and the Z, but we need to find the number of neutrons. Basically, that's very simple. We will subtract A and Z, the mass number from the atomic number, to find the number of neutrons inside the nucleus. So why is this number called the mass number? Well, since it's the number of protons and neutrons inside the nucleus, the mass of an atom is concentrated inside its nucleus. Usually, in a neutral atom, the number of protons is equal to the number of electrons. So, Z would be equal to the number of electrons as well. So, the mass number is equal to the number of protons and neutrons in the nucleus of an atom, and the atomic number or proton number is equal to the number of protons in the nucleus of an atom. Now let us take an example. Here we have the element argon, represented as Ar, and it has a mass number which is equals to 40 and an atomic number or proton number equals to 18. In many cases, you will be given the atomic symbol, the atomic number, and the mass number, and you'll have to find the protons, neutrons, and electrons. Now take a minute and try to find the number of each subatomic particle, and then check your answers. Okay, so let us start with the number of protons. The number of protons is equal to the atomic number, which is written at the lower left. So the number of protons is equals to 18. Now for us to find the number of neutrons, we must subtract A from Z, the mass number from the atomic number, which is 40 minus 18, and this will give us 22. Argon is a neutral atom, so the number of electrons will be equal to the number of protons. In other words, the number of electrons in a neutral atom is equal to the atomic number Z, which is 18. So these are the number of subatomic particles of argon. Now let us take another example. In this case, we have a neutral atom, calcium, which has 20 electrons. Now we'll have to find its mass number and its atomic number. Since calcium is a neutral atom, it will have 20 protons as well, since the number of protons is equals to the number of electrons. So the atomic number Z, or the proton number, is equal to 20, since we have 20 protons. We're given also that it has 20 neutrons. So now we have to find the mass number A. Mass number A equals to the number of protons and the neutrons inside the nucleus. So 20 plus 20 equals to 40.